Hello, and in this video we're going to talk about topic 6.11. We're using integration by parts. So we're going to answer the essential question, how to use integration by parts, and our two two I can statements are I can integrate by parts, and I can integrate by parts and use the tabular method. So up to this point, we have not discussed how to integrate the product of two different transcendental functions. The method that we learned in this section will finally allow us to do so. With it, we will have the ability to integrate problems such as the integral of x times the natural log of x squared times e to the x dx, and e to the x sine x dx. So basically, the integration by parts is really based on the formula for the product rule in derivatives. And that's how you recognize that you have it, is it looks like something where there's a product and you would have to take the product rule if you're doing derivatives. But basically what happens, the formula is if you are, that when you have the product rule, you have the u times the derivative of v plus v times the derivative of u. So that's kind of what it's based on. So if u prime and v prime are continuous, you can integrate both sides of the equation. So when we integrate both sides of the equation, we would end up with, let's see, you've got u to v prime dx plus v, the integral of v u prime dx. V prime is the same as saying dv dx, and u prime is the same as saying du dx. So we know that uv equals the integral of u dv, because the dx is canceled, and plus the integral of v du, which means the dx is canceled here. And if we were to rewrite that a little bit, and I were to take, let's see what happened to get here. We would have had to subtract this to the other side, and that gets us the integral of u dv. So when you see something like this, we want to try letting the dv be the most complicated portion of the integrand that fits a basic integration rule that we know. So is it sine? Is it an x? Is it something that we know how to integrate, that's complicated but fairly easy for us to integrate? You will be the remaining portion or the integrand, and you should be able to take its derivative. So whatever u is, we should easily be able to take its derivative. So I typically will draw a box over here for my u and my v. Okay, and I'm going to decide what u equals and what v equals, and also then what is du and what is dv. So I kind of fill that in. I probably should have written it just a little bit bigger. So I want my dv to be the most complicated portion. So this part here looks like the most complicated portion, so I'm going to use that. Then I'm going to integrate it to get it up there. So when I integrate e to the x dx, I know I get e to the x. We're not going to put the plus c's in at this point. Now we're going to put this in as the u and take its derivative, would just be dx. Then we are going to use this formula right here. So we know that the integral of x e to the x dx equals u, which is x, times v, which is e to the x, minus the integral of v, which is e to the x, times du, which is dx. And we have a little bit extra to integrate here. So we've got x, e to the x, minus, when I integrate e to the x, I get e to the x. And now we finally add in the plus c. And a kind of shortcut way to remember this here, I should do it in purple actually, okay? The shortcut way to remember it is to remember that it's ultraviolet. So UV, voodoo, right? Even I know that's spelled wrong, but it's voodoo, so it's VDU. That's just a shortcut way of remembering it. All right, let's try integration by parts again. So I know I recognize I have integration by parts because I have a variable times a variable, and something that's also transcendental or a trig would go in there really well. So I am going to go ahead and draw this box. You don't have to draw the box. It's just the way that I organize it. I've got u and du, and then v and dv. So I'm going to try to pick on the more complicated part that I actually know how to integrate. I do not know how to integrate natural log at all. So I'm going to pick on the x squared dx as my dv. So I'm going to use x squared dx. And then I'm technically going to integrate both of these sides here. So when I integrate, I get x cubed over 3. So it was complicated, but it was also something I knew how to integrate. Du, or u, on the other hand, I'm going to use the natural log of x. The derivative of the natural log of x is 1 over x dx. All right, we're going to fill in our formula. So we know the integral of x squared natural log of x dx equals ultraviolet voodoo. So u, natural log of x, v, x cubed over 3, minus the integral of v, which is x cubed over 3, du, which is 1 over x dx. I totally squished that in. Let's rewrite a bit. So I would probably put this x cubed over 3 in front of my natural log of x. I'm noticing that x goes into here once, so I would really have x squared. I'm probably going to move the 1/3 out front, dx. That's much better to integrate. So we've got x cubed over 3, natural log of x, minus 1/3 x cubed over 3 plus c. And then we've got x cubed over 3, natural log of x, minus x cubed over 9 plus c. All right. The next one we're going to do, and we're not going to do the, we're going to ignore the fact that it's a definite integral. We're just going to do the indefinite integral on this one. So we're going to do an integrand with a single term. So this time you have to ask yourself again, I'm going to use my little box, right? And I'm going to put u, du, v, dv. So if I'm going to put it in dv, I want to pick something, the most complicated thing I can put in there, but I have to be able to integrate it. I do not know how to integrate arcsine. Okay, so I'm only going to be able to put dx here. When I integrate dx, I know that I get back to x. All right, so arcsine has to then be my u. So arcsine x is going there. We know the derivative of that is 1 over the square root of 1 minus x squared dx. All right, so let's put it into our formula. So the integral of arcsine of x dx equals, I'm going to put it on the line below so I don't run out of space. The ultraviolet voodoo, so arcsine x times the v, which is x, which I'm going to throw in front, minus the integral of v, which is this x, over the square root of, because this is du, right? 1 minus x squared dx. All right, we have to integrate this. Guess what we get to use? We get to use some awesome u substitution. Doesn't that sound exciting? So we've got u equals 1 minus x squared, du equals negative 2x dx. And I should have really written that in blue, huh? So I don't have I have the x dx, I don't have the 2, so I'm going to put a 2 on the top, 1 half, and a 2 on the bottom. Let's do our u sub step. So I've got x arcsine of x minus 1/2 the integral of, I'm going to do a bunch at once. So we've got u, I know it's to the 1/2 power, plus I want to bring it upstairs, so that's going to make it negative. And then for the 2x dx, I am bringing in du. Now I am finally ready to integrate. I should have written smaller. So we've got x arcsine x minus 1/2. I was going to, and I really should have used something besides u. I should have really made that w instead of U, just because I already had a U in the problem, so it's probably better to make it a different variable. When I integrate, I add 1, so I'm going to add 2 over 2, which is going to make it 1/2, divide by 1/2, or multiply by 2, plus C, and put my final answer out here, sorry. We have, these are going to cancel, so we've got x arcsine x minus, instead of W, I'm going to substitute this in. And I could make it a square root if I wanted, because it's a 1/2 power, 1 minus x squared plus C. All right, we're going to do one more, and I'm sorry I did not split the video up like I should have. So the last one we're going to do is we're going to have to use integration by parts more than one time on this one. So we have we're going to get out our table. Okay, so we've got U and du and dv and v. So I want to pick the most complicated part that I know how to integrate and put it here. I do know how to integrate sine x dx. That seems a little bit more complicated than x squared, so I'm going to put it here. And again, if we pick something that doesn't work, we can always pick the other thing and go back. So I'm integrating both sides. When I integrate sine x, I get negative cosine x. So that means that my u has got to be x squared, and my du has got to be 2x dx. All right, let's try to set this up. So we've got the integral of x squared sine x dx equals u, which is x squared, v, which is negative cosine x, minus the integral of v, which is negative cosine x, du, which is 2. Ooh, interesting. Look at what's going to happen. I'm going to remove this a little bit. 2x cosine x dx. Double negative is going to go positive here. Look at what happened. I have 2x times cosine x. I'm going to have to do integration by parts a second time. So I know I really shouldn't use the same variable, but I think we're just learning this, and it's probably easier for us to stick with the u and the du and the dv and the v, just so we aren't, because we totally understand it. So this first part, just getting written the way it is, negative x squared cosine x plus. All right, my more complicated part that I know how to integrate would probably be cosine x dx. I'm going to integrate both sides. When I integrate cosine, I get sine x. So that means that 2x is the u and 2dx is the du. All right, so here we go. We're going to have u, which is 2x, v, which is sine x, minus the integral of v sine x times du, which is 2 dx. We've got negative x squared cosine x plus 2x sine x minus 2. When I integrate sine, I get negative cosine x plus c, and that's going to go ahead and go positive.